mean, training a large model is absolutely insane because it requires like a lot of, it requires a lot of like a whole team, a whole data set, you know, like there is a lot of efforts going behind these large models that's out there and famous. But you can definitely do like smaller projects that, you know, one could do. And we used to do that early on, right? It does give you that experience, that understanding what's happening.
Yeah, one thing is interesting. I thought prompt engineering was like for losers. Like I thought you weren't. I thought it was like really simple.
Yes, it is very simple.
It can drastically change the output.
Exactly.
So, could you like tell everyone like who you are? What do you do? Yeah.
So hi everybody, I am Sakshi Agarwal and I am an AI research scientist. I got my PhD from UC Irvine in computer vision, and before that I was born and brought up in India and got my undergrad in India, worked there for 2 years and then came here for my PhD. And
cool. And how did you decide to do like a PhD?
I think it was the 2 years after my undergrad that when I was working in my company, it was also like my position was budding scientist.
Okay.
So it's someone who, you know, thinks in the research kind of directions and is given like small industry like projects.
Okay.
And they're asked to like, you know, see if they can do some innovation in those regimes. And that's where we were working on like some sort of classification problems. And I saw that was like the repeated problems that I was facing. And I wanted to understand a little bit more about what machine learning could do. And I thought that there could be more richer models actually that we could build and tackle more like broader problems.
Okay.
And that's when I decided to do a PhD actually.
Okay. So then when you were in your undergrad, you were like, I guess doing research, working under like budding research, and you were doing like, I guess the machine learning stuff. And then you were thinking, okay, well, these models are probably going to get stronger. So then I want to keep doing this because like there's going to be really cool stuff, I guess, that's going to be happening.
Right, because a lot of the classification kind of problems entail models to do that one task. But my thought was actually like, what if models can read from other sources of data, right? What if I can enrich that kind of information, say from the web or other things, and make the model stronger in that way and just not limited to like an input-output regime. So that was my direction. Like, let me look a little bit more into how it can get access to more data and become more reasonable, become more smarter. So that was the direction I wanted to go.
Yeah. Okay. And like, how did you... Was it just like obvious that the models were going to get better, or like how did you know that? Because also, I mean, I think you like I feel like maybe a lot of the PhDs right now who went into the AI stuff are in a very unique case because AI has exploded. Like AI is kind of just dominated and taken over like everything. And so it was like did you like, I don't know like how much went into or how much planning. Like for me, when I was in college, I was like, okay, there's a lot of like, I would love to do AI, I would love to do machine learning, but I didn't think I had like any of like the knowledge or skill. Like I think you need to get a master's degree if you want to get a job and stuff like that. So like I just didn't bother with it. But I guess we'll talk about it later. But like, yeah, I guess like how did you know that models were going to get better, or like why did you think that models were going to get better?
Yeah, I had actually researched at that time a lot about what these universities were working on. And there were some like great ideas that I thought was worth exploring. So those were the ideas about like constant learning from the data. There were like many research projects that like I think CMU and a lot of these other universities were doing, where they would constantly let the models learn from data. And I thought that was very powerful. And then there was also big data sets that they were enriching with graph-like data.
Okay.
that I thought was very powerful in terms of, say, question answering or just like a big database that you would have, right? That's so powerful. So at that time, I thought I wanted to do those kind of algorithms and dive into those kind of machine learning techniques. I mean, now something different has happened, and a very larger scale that I didn't expect, of course. But those kind of ideas that I was convinced was going to be the leap forward.
Okay. And did you, I guess maybe taking a couple steps back, like, so one, when you did computer science and you started doing that for undergrad, how did you decide on that?
So my undergrad degree is a mix of electrical and computer science.
Okay.
I went in as an electrical engineer major.
Okay.
And then somewhere down the line, I think in my second year, which was very soon, I realized I don't want to be the hardware kind of engineer. I don't want to be in labs and connect these wires and stuff. That's not very exciting to me.
Yeah.
I think the exciting part was like that time making machines think, like those two words was just so exciting to me.
Yeah.
And as soon as I heard the word machine learning, I wanted to know what these algorithms were, and I started just blog posts or simple material online. And my first project was actually in the US on machine learning, where I was in the research experience undergrad program in Duke.
Okay.
And that's when I first came, I was exposed to machine learning.
Yeah.
And that was the start of it.
Yeah, that's great. So you were at Duke?
Yeah.
That's crazy. Yeah.
For the summers, like 3 months.
Yeah, that's insane. It's very hard, very difficult school.
Mm-hmm.
And okay. And did you one thing, I have a lot of questions too on the AI stuff, but I guess, how hard do you think it is to get into AI, as someone who doesn't, as I guess for the people, there's with all the AI hype, right? For software engineers who want to get into AI, how hard do you, I don't know, could you explain what is the kind of area of AI? Because I think there's machine learning, there's also deep learning, and then there's also, I guess, the generative AI stuff. I don't know,
right.
But what are those things? And then I don't know, it could, how much math is needed? I don't know, can software engineers pivot into that as a career? I don't know, but yeah.
Yeah, that's a great question, because I also get asked that a lot from other people. My brother, in fact, is a software engineer, and he recently was like, "Oh, can you share some sort of material for me to dive, deeper into this, and maybe I can explore and add some skills onto my CV?" Because now I feel like that's very important for software engineers to sort of keep pace with.
Yeah.
I think that for software engineers to enter AI problems or something, tackling those things, I think one of the major skills would be prompt engineering a little bit.
Okay.
That would be, because that's the top layer of how do you interact with these models. And just getting to know how these models behave for certain queries, and kind of treat the model first as a black box and sort of understand and analyze what they do.
Okay.
Right? I think that is sort of the first step to me.
Okay.
And then once you want to get into the math of it, right? I think there are two levels, right? One level is just building wrappers around these AI models, understanding what they do best, and kind of just building that wrapper and sending it in. That's one level, right?
Okay.
The second would be, okay, now I want to know a little bit more. I'm curious about what these models do and how they do it and why do they react in those certain cases.
Yeah.
So that would be okay.
How to implement one, maybe.
Yeah, how to implement one, how to train one model, I mean, training a large model is absolutely insane because it requires like a lot of, it requires a lot of like a whole team, a whole data set, like there is a lot of efforts going behind these large models that's out there and famous. But you can definitely do like smaller projects that, one could do. And we used to do that early on, right? It does give you that experience, that understanding what's happening. There are definitely many levels to understanding the math behind AI, but based on one's interest, I think they could, channelize that and then do some small projects and learn from them.
No, that makes sense. And that's really, I think it's really huge. Like one thing is interesting. I thought prompt engineering was like for losers. Like I thought you weren't. I thought it was like really simple.
Yes, it is very simple, but it is a must in the sense of like it does tell you how to sort of use these models. It is one of the overhyped things, to be honest, like prompt engineering. You're just neatly writing prompts. That is it. But to some extent, it is useful.
They can drastically change the output.
Exactly. So that is something to know. But yeah, of course, I don't think you should overhype that. So
I saw things, they were saying that there's going to be like, that's going to be like the new job. I feel like 2 years ago, it was like prompt engineering will be the new job.
No, it's in my head, it's not a new job. I feel like that's something that everybody should be aware of when they're working with these models, but it doesn't it doesn't seem to me.
I don't think it's happened. And I think now like the talk right now is that now it's AI agents. And so like the new job is going to be someone who can interact and like, wield 5 AI agents and manage those things.
So the AI field is moving super fast. And as you can see, there was AI, then there was prompt engineering, and now there's agents. I'm sure coming NeurIPS will see another term that we don't know about. Like these terms are just, exploding. They're just like shift. And it's bizarre to me how these jobs actually become like agentic or, prompt engineering. I think the core ideas we should have as machine learners or, AI enthusiasts, like we should know the core ideas behind it, and then everything is just like building up on top of it. So for example, an agentic framework, right? Like what is an agent? It's just using these AI models for some sort of tasks. And now you've written those prompt in a specific way to guide that agent to do something with the input data. So now you've like created sort of like a wrapper that this LLM will be guided by this prompt to do some task. So like the concepts are building on top of the previous things, but as the concepts build, there's also new words and terms coming up.
So for the software engineers who want to get inside, then like how much, like, because you did say there's like levels, and I think that like just doing that is already like a ton of stuff. Like whatever you said is like already like a ton. Like so like training the models, learning prompt engineering. I think you could probably read a guide or something. Like I think Google's produced like maybe like a 40-page document. I think that's on it, just prompt engineering. But like so then from what I'm hearing then is that like you don't really need to, like if you want to pivot into AI stuff, you don't really need to like learn like the math stuff and all that. No, as a software engineer.
I think
or what's the math useful for? I don't know.
The math is very useful to give you like a deep understanding of what these models are doing. So say there is a next model that comes up, right? Because I have a PhD, because I know the math behind these things, I can quickly read it up and I will know why these models behave in a certain way.
You can quickly read it up?
Like read the paper.
Okay.
Like there, maybe there's a published paper. I can reference that.
Okay.
And maybe there was this one new trick that somebody implemented and came up with, and that worked. So that gives me the ability to sort of like brainstorm and be like, okay, what cases could that fail? what cases could it be better for?
Yeah.
Why would I choose that over this existing model?
Yeah.
So those kind of things do become easier for me to make a decision on.
Yeah.
So that's why I think the math would be important.
Okay. Cool. Yeah, that makes sense.
Because otherwise I would just like use the model and expect it to do everything.
Yeah. And what's the difference, or what is like deep machine learning versus like deep learning? I guess, yeah. What is that like versus like the AI? I guess generative AI stuff.
Yeah.
For someone who's like new, I guess.
For someone who's new, yeah. So machine learning talks about a lot of algorithms that was, say, like, came up very early on, like support vector machines, or like just some traditional algorithms that didn't involve like large sort of models. It was simple in nature, right? Like they were the start of machine learning is what I, vaguely I can say.
Okay.
And then there was deep learning that came in. Now, deep learning was built off of one of these traditional machine learning models, which was the neural networks. So what they did was, people were trying out like neural networks with, say, some n number of layers in the order of like 10 or 15. And what happened was, I think in 2010s, they took the idea of these number of layers to go to hundreds. So that's where the depth in the model came up, and the concept of deep learning came up. But deep learning is nothing but like, extending more and more technologies or techniques or methodologies behind neural networks, working for like large data or improving predictions and things like that.
Okay, cool. Yeah. Okay. Cool.
And now we are in the phase of generative AI, which has happened like very recently.
Yeah. Also, I'm kind of curious if my definition is good, right? My understanding of generative AI is that we have, like, you can map on words, I guess, to like numerical values, and then you can like relate those into like a dimensional kind of grid, I guess, and then use that with plus, I guess, the machine learning stuff to generate like an output between like what should be the expectation future value, like based on like these related kind of words or whatever in a dimensional grid, like what should be the expected output, and training it on that. I don't know.
So you are right in your understanding that you map the words to numerical values, and then there is, of course, like the neural networks that I spoke to you about. Essentially what they do is matrix multiplications. That's what they do in the like number space, right?
Okay. So I took linear algebra once.
Exactly. So that's what it's doing in a very, 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 very high dimensional space.
Okay.
And that is actually like, that was the start of deep learning. So words get mapped to like some numbers, and then you play around with these numbers, you find similarities, distances, and then you do the predictions. So all of that concept actually came up way early on than just generative AI. Generative AI became a thing after transformers came in, and people built off of that idea, came up with large language models, and those models became great in terms of just generating sentences, longer paragraphs, and the fact that people could use these models to do like crazy, tasks or whatever they wanted to do it. Yeah. I think that's when we started with generative AI.
Okay. And your specialization was in image generative AI.
Right.
Okay. Well, what do you think image AI is like overhyped, and where do you think it's like underutilized, like underappreciated or underhyped?
Right. So image generative models. Yeah. What was the first question?
Yeah, where do you see it as overhyped, specifically for image AI? Or I don't know if you look at it like, but like for example, I'm seeing like tons of stuff that you can use. I'm seeing tons of people using it for like advertising, right? So AI advertising. It's actually, honestly, it's really good in some cases, where you can very quickly put out ads. You can very quickly put out content. So like YouTube videos, there's a lot of like AI YouTube videos that are out. There's a lot of there's just tons more content has gone up. I think YouTube actually even put a ban out. Not ban, but they said it's not monetizable to stop people from putting so much. But like, I don't know, I guess like where do you see the use cases with image AI? Like where do you think it's like overhyped, or where do you think it's, really needs, like you wish there were people who were just like, oh my God, you guys should like totally do this, or like try to learn this so that you can do this. Yeah.
So the generative models for images are doing great. Like they've definitely improved by a ton. But the problem is that when you see an image, you can clearly see where it went wrong. So for making it like building a product out of it, or I think it's easy to do marketing based on that, because you can just pick the pictures that worked for you, right? Like pick the pictures that nobody can say anything is going wrong in that photo, and then you can just do it. You can just use it. So that's a great application, an easy application, and you can do it.
Have you seen the kangaroo video?
I have not.
There's the AI video. It's a kangaroo trying to enter the airport, and they don't let him in.
Yeah, you can definitely.
In the comments, people were like, "I thought this was real."
Yeah. So the scary part over there is that there is a lot of videos that can seem real to you. Thankfully, I work in this space, so I have not been like duped with that, because I can see like this is definitely AI generated. There is definitely some content that I love that is, I know, AI generated, but it's very creative, I have to say. But it's hard to ignore it. That's one societal impact, I would say, with image generation. I guess with text also there is some kind of impact, but text? Like for image, there is, you can see it. It's very visual, right? Like so you don't want, say for example, kids, right? If you show them like an image versus some sort of text, they're gonna see the image first, right? So I think there is something behind this, that like the generation of images really need to like improve to a very higher scale to be able to be used for products.
And what products do you mean when you say that?
I don't know, I haven't thought too much about it. I feel like most of the use cases comes to me on social media, as we are talking about.
Because there's things, I guess it could be t-shirts. I guess that's something people put images on, maybe making t-shirts or clothing. There's an AI startup that's letting people use AI to make, that I interviewed for maybe a couple months ago, or 6 months ago, 8 months ago, I think. But they're doing jewelry, so people can type in their jewelry, like I want a thing that looks like this, and they generate the thing, and they actually ship it. So they connect it and say, hey, build this piece of jewelry. And then then it goes to your house. But that's the idea behind it. So a lot of applications around art is also being like AI is playing a role in art generation. So one of those applications, I feel like it's reasonable to use them for ideas, right? We can all some creativity is fine, and once you sometimes you can think about something in words and not pictures, and so AI can definitely help you translate that into pictures, and then you can do that back and forth, and sort of you can come with a great Yeah.
suggestion.
Yeah. What's something that you're like really, really excited for to see in like the AI space that like, it's very likely going to be here and it's just like the day is going to happen? Or what's something that you're like this is so annoying, like if only someone made this app that like just lets me do this, like I know it's totally possible, I'm not going to do it, but like
Yeah, that's a great point. I think the one thing that really annoys me is like getting humans right in these generated images.
getting humans in the images.
Humans.
Yeah.
And the fingers, like it's always so like scary to look at these images with humans in it.
Okay.
You would always, so one thing, actually this is a good thing to see in current AI generated images, you would see there would be less number of people. That's one thing to be wary about. Like
less people. Okay.
Less people in those generated images.
Okay.
So you can say that maybe this was something AI generated because they are still not there.
So they can't make an image with like 100 people.
I think 100 people, like small little dots, would be easy for AI. But like
okay, I understand.
I mean, every time if you've seen people in AI generated images, they are mostly faces, right? But it's not like a entire body doing something with fingers holding or whatnot. So it's still yet to cover that bit. And it's kind of annoying to just see like humans being the wrong thing predicted. But that should happen soon.
Okay. Yeah, so you totally think it's possible. Okay.
I yeah, of course. Yeah, I do think it's possible.
Oh, that's scary. That's scary.
That is scary.
Yeah. Okay. Okay. And then I guess do you have any? Do you know anything for videos, or like do you know how any of that stuff works, or like is it just a series of images spliced together?
No, there is other kind of improvisation in these generative models, taking videos in mind.
Okay.
The series of image generated and putting them together is sort of like the naive approach.
Yeah.
But of course, there's like tons of work in that space.
Okay.
Currently, I have seen impressive videos which are short, 5 second. Somehow this magic works with all models I've seen, and they like to have a 5 second rule of generating images.
Yeah.
Where there's only like certain frames and then done.
Yeah.
So longer images is still a question. You know how early on there was like longer sentences generated was a big question in the text space or the NLP.
I didn't know that.
That was a big thing, that it cannot the big problem then was generating sentences or paragraphs was a problem. But now we are there. Like it does a pretty good job in generating like one page or multiple pages. I don't know.
Yeah.
So it will get there.
Okay.
Videos will be generated, which is longer.
Okay.
It's still in the 5 second space.
Okay. Yeah. Okay. No, I kind of thought, I was thinking of a joke. I was going to ask you, but I wanted to have a serious face. But I was going to ask you, can somebody use an LLM to write their PhD paper?
Oh my God. I bet somebody's tried it.
Yeah.
I have not.
Yeah.
But I bet that has already happened with some students.
Yeah.
And I do think that it can. And I know that some papers are also generated by LLMs. It does a pretty good job in citing papers, in making everything sound reasonable. And if you read it, if somebody with that background reads it, they will know for sure this is LLM generated.
Yeah.
But how many times do people read PhD dissertations, right?
Yeah, it's a lot. It's a lot of words. A lot of words.
Exactly.
Yeah.
So sometimes you just need something pretty out there,
Yeah. Okay, cool. So just the last couple questions, I think, is like, so you did like the long hard fight, got your PhD, and like now you're working. So like, how do you feel that different? what do you like? What don't you like? I don't know. Which do you prefer? Would you recommend someone who's watching go get their PhD in AI?
Right. That's a great question. Let me talk about myself, and then I can come to the latter question. So PhD was tough. It took me 2 years to finish my master's, and then like 3 to 3.5 to get my PhD after. So it was a total of 5.5 years on the same campus with my same advisor.
Yeah, just working on the same project.
Similar idea, like similar problem space.
Okay. But like just one project. Like I don't know what happens in a PhD, but
so
I think it's like one. Yeah, you want idea, or I don't know.
So what happens in a PhD is that you want to specialize in one problem space.
Yeah.
So you pick one problem space, and then you kind of want to have like multiple papers or multiple innovations that happen in that space. So for me, it was image and painting, and I was doing multiple works regarding keeping that in mind. So and the graduation policy is very different with different labs and advisors. For me, it was okay, if you get 3 first author papers, you're good.
If you get 3 papers?
3 first author papers.
Okay, so first author means you wrote it.
Yeah, like I was the lead. I worked on it the most. That sort of thing.
Oh, okay. And how do you make a paper? Is
that means how do you make a paper?
The scientific community agrees on it? I don't know.
So it's a long process from like, okay, ideation to proving this idea works to showing how these ideas work with some sort of experiments that you design. And then you write it all up, documented, give intuitions to the readers why this would work, and then show them with experiments. If you have a proof, you write them down, so like very well documented. Okay. And then you submit to conferences or journals, and there's a process behind that. So there are reviewers out there. There would be 4 or 5 anonymous. You don't know who your reviewers are. Reviewers don't know who you are. Yeah. And they kind of go through that process. They give their opinions, some space where, some comments on how this paper is amazing or needs improvement on. And then there is a score that they give you. And then you want to be on the higher side to get accepted. Okay. Once that's accepted, this cycle has done, and then you start another one. Yeah. Okay. So you did that 3 times in 5 years. 3 times in 5 years. Okay. Because the first 2 years is you basically taking more, machine learning courses, trying to understand the space a little bit. Yeah. So I think I started researching, at the end of second year, I would say. First 1.5 was like sort of pure courses. Yeah. Okay. And then, okay, cool. Yeah, so you said it was really hard. Okay. And yeah, how does that compare to being a full-time employee? Yeah. The first thing that comes to my mind, I tell everybody, is that the pay is amazing. Being in the industry, you have a regular good paycheck. You can do so many things. So let's get that out of the way. Nice. And then regarding work, my work, I don't find it super stressful as PhD was. PhD has like a lot of pressure on you. You kind of need to keep coming up with ideas, making things work, doing the submission process. It's so bad right now with so many papers being submitted to conferences. There's an overflow. So there's too many people submitting papers? Yes. Just because there's too many PhDs, or? I mean, there's also the fact that it's faster to write papers now because of LLMs. Because of LLMs, and many people use it, and now I think it's even acceptable at conferences. That's crazy. That it's okay for you to use LLMs for grammars or correcting some bits and stuff. Well, that's crazy. So the output of PhD papers, I guess, it's increased so much. Just from that, I mean, that's crazy because I imagine the same stuff is happening with YouTube. Like basically YouTube, Instagram, people are dumping just content because it's so much easier. Mm-hmm.
The LLMs.
And it's hard to manage because now all of a sudden there was, the bar was here and now it's all of a sudden like twice, and it's only going to grow exponentially maybe.
Yeah.
But so it's very hard to manage this.
Okay.
And so now it's become like a very tedious process with, if your idea was good enough, there's been setbacks in getting it out there for people to actually like read your paper, read your work, and actually showcasing it. So there's a lot of problems happening with the publication aspect of things. There's like reviewers only wanting to see like, one kind of ideas, and other ideas kind of get a setback, which is not ideal. You don't want that.
Okay.
But so currently I'm not under that pressure, right? Like trying to, publish something because I have to graduate.
Yeah.
Like all of that pressure is away, and I'm doing like a regular job where I'm definitely putting a lot of the skills that I learned during my PhD, but it's not like, it doesn't have that pressure.
Yeah. So overall, more pay, less pressure. So I guess overall better. Would you recommend someone who just graduated, got their master's to get a PhD?
It highly depends on your interests. And now it's not only your interests. I think now it's very important to also weigh who you would work with as your advisor, because that's going to be a long time of your PhD that you're going to work with him or her. And then, but in the meanwhile, industry is moving at a very fast pace, and you don't want to put yourself in a position where after 5 years you have, you've taken a bet on something, and now, industry has gone in a totally different trajectory, and the skill set has changed, and you just don't want to go through that path. So you really want to make a very informed decision before going into the PhD program. It is great because it gives you like a lot of skills. You do develop a ton of skills, a ton of leadership skills, because while you're developing those papers, you know how to lead on certain kind of work, how to delegate some small tasks to your colleagues. So a lot of those formalization happens. So that skill set is great, and I don't know if you would develop a lot of that in the industry. You would just keep going at some pace. But I think it's the advisor, connections, interests, everything need to align to be in a sweet PhD program.
Yeah, nice. And okay, cool. And then what are you? There was something. I wish I had my notebook. I should have had it, but whatever. But I was related to the careers and like the programming. I guess like so. Right now, I think you're working with the AI stuff. And at the same time, I guess kind of just doing a mix of kind of like everything with also like a little bit of programming and all the other stuff and agile and everything. Like what do you see as like what makes like a really good like colleague for you, right? So like if there's a software engineer who's going to try to work alongside someone who's doing AI, like basically like what are you looking for when they're hiring somebody? Like what do you look for in a coworker? What do you in a good coworker?
So I've been trying to feel like in the last few months, I have this idea that someone with a PhD, I think would work great with someone with like an applied engineer, someone with, that software engineer background, wanting to work with the PhD to build something. Because I don't have that expertise on the software engineering skills that you would have. And I think both make a great team. I can formalize these open problems that's out there, and we would need to tap in and, come up with like a lot of things. And once it needs to be productionized, I, come work with you, and then we can, make sure that it integrates well together.
Okay.
So I think that is really, really powerful.
Okay. So then it sounds like one is that like software engineer, like a really cool thing, or at least the way like they could level up just a lot higher rate is if a software engineer partners with someone who's a researcher, someone who has like that really, really strong background
Right.
on that theoretical side and can build something.
Right.
Yeah, because they can leverage kind of each other's skills.
Exactly.
Yeah. And so then I guess it sounds like basically what I'm thinking is like, okay, well, you're working right now, like if a software engineer comes in, like you don't really care if they have if there's someone who's going to be your coworker who's going to help you on your task or whatever for your team, whatever. You don't really care if they have like that background of like I guess all of the math and stuff like that. Like basically if they hit like those points earlier that you kind of mentioned, which is like, okay, prompt engineering, and then knowing how to train data sets and things like that, like those skills would be good for you. And it could even be communication too, right? So you could even say like, oh well, I want to have a coworker who just like can communicate very well, who can tell me their ideas clearly, things like that. But like I don't know, but whatever.
Yeah, so okay, let's talk about now, right? Now, currently, there's definitely help from AI to code.
Yeah.
So there is one question where like, okay, do you even need a software engineer for that?
Yeah.
But I think even now, if I was to build any platform or a solution, I would definitely hire and have software engineers on my team working in sync with research scientists or research engineers. And so definitely at this like currently, software engineer is very valued.
Yeah.
There's definitely maybe like the number would go less because of the help from AI, but I would definitely have them.
Yeah.
Now, moving on from like, okay, software engineering skills plus some other skills in the AI domain, as we discussed earlier, the prompt engineering and those little things about training. I think there is less emphasis on training these days because there's so large models.
Yeah.
But that can come up
like
and that
RAG?
can change. Yeah, exactly. So there's like a lot of like inference time.
Or like agents, RAG, stuff like that.
Exactly. So those are inference time algorithms that has become like very important to know these days. So I think those tools are very good to have, good to know.
Okay.
Because they build on top of these models, right?
Yeah.
And so I think those are things that would be reasonable for software engineers to also tap into.
Okay.
And would be like good to do.
Okay. Yeah, and it could also just be none of them, right? Like if it like my question, my kind of point with that question is just like, okay, so I think you're doing AI stuff at your current job. And like if a new engineer comes in, what do you want them to prepare on? What do you want them to learn? And how do you want them to be effective in order to help you with building the AI stuff? Yeah.
Yeah. Oh, that's a great question. Yeah, that gives me more perspective. A very concrete enough answer is what I have actually is the software engineer, of course, is building this complicated, code base using these AI models. So a great again, I would just say two levels. First level would be their already skills that they have. The second would be the inference time algorithms that we discussed. That would be like a plus. And I would love, if I'm working with the software engineer, if that person knows these inference time algorithms, they can already do so many things with the current existing models out there.
Yeah.
And they could give me insight with, a ton of projects itself using those algorithms.
Yeah.
They don't need to train anything. They don't need to do anything. They just need different models to talk to each other.
Yeah. Cool. All right. Well, that's basically it. I mean, actually, do you have any advice for any people who are in college studying computer science? Like what, I guess there's someone who they just started computer science. They're not really sure what they want to do, I guess.
Yeah, that's a great question again. I would say as an undergrad.
Or actually, my bad. Actually, no. Give your answer, and then I actually have the second one. Yeah.
Okay. As an undergrad, if you're in computer science, I would highly, highly suggest that you take up math and take up machine learning courses. Diversify as much as your interests can, want to. Basically, you want to diversify and not put all the balls in one computer science regime.
Cool. And second thing is, what would you say to someone who's a master's student, right? So they graduate, they have the bachelor's from a different country, and they come to the United States for a master's degree, with the hope of making more money or whatever, but they're on that path. Well, what advice would you have for them?
So are they should I assume?
Yeah, computer science, yeah.
Okay.
Master's computer science, yeah.
Now they're masters in computer science.
Yeah.
So, I mean, should I also assume that they are interested in machine learning and AI? Because there are other.
No, they're interested in having money.
Okay.
Yeah.
Yeah, that's a great anchor point as well. So if that's the case, honestly, AI related currently, hardware or software, you're gonna there's all the money there, right? Like if you are creative, come up with ideas, you can probably start your own, startup using these models.
Yeah.
A lot of them are open source, so you can really just use them and build something on top of it.
Yeah.
Yeah, there's a lot to be done in this field. So hardware or software.
Cool. All right. Thanks. Yeah, no, thanks a lot. And I think it was really super, super informative for sure. I learned a lot. So
yeah,
cool.
Thank you so much for having me here.
Yeah.
And this was amazing, a lot of fun. This was my first, but yeah, I liked it. Thank you.
Cool. Thanks.